Hello friends, welcome to my channel Mathematicos. Today's discussion is on the chapter Squares and Square Roots for class 8. In this video, we will discuss exercise 6.3 question number 1 to 4 taken from the math textbook Ncert. So let's start. Question number 1 says, what could be the possible ones digit of the square root of each of the following numbers? So we have to find out what will be the possible units place digit of the square root of these numbers. So as we know, square root is nothing but the inverse operation of square. That is, if 3 squared is 9, then the square root of 9, so the square root symbol is this one, so square root of 9 will be 3. So square root is an inverse operation of square. So to solve this question, we'll need this table which shows that unit digit of a square number and unit digit of its square root. We'll find the relation. As we know, a square number always ends with 1, 4, 9, 6, 5 or 0. So this table shows that if a square number ends with 1, then its square root will end with 1 or 9. In the same way, if it ends with 4, the square root will end with 2 or 8. If it ends with 9, its square root will end with 3 or 7. Similarly, if it ends with 6, the square root will be ending with 4 or 6. And if the square number ends with 5, the square root will end with 5. And if it ends with 0, its square root will also end with 0. So, following this pattern, let's solve the question. The first number is 9801. So we have to find what will be the units place of this square root of this number. So 9801. If we find the square root of this number, the number that we get, the square root will get, the ones place will end with 1 or 9. As you can see here, if the square number ends with 1, the square root will end with 1 or 9. So the possible ones digits are 1 or 9. Now the next one, 99,856. So you can see here in 99,856, the units place is 6. So the square root will end with either 4 or 6. So the square root will end with either 4 or 6. The next one, as it ends with 1, the same way, the square root of this number will end with 1 or 9. And the last one, this number ends with 5, so its square root will end with 5 as per this table. Next, without doing any calculation, we have to find the numbers which are surely not perfect squares. So for this, we'll follow this table which shows the number and its squares. As you can see here, the squared numbers ends with 1, 4, 9, 6, 5 or 0. None of the square numbers ends with 2, 3, 7 or 8. Hence, following this rule, we can say which of them will be perfect square, which of them will be not perfect squares. So first, starting with 153. In 153, the ones place is 3. Since the ones place is 3, according to this property, we can say this is not a perfect square because a square number never ends with 2, 3, 7 or 8. So 153 is a not perfect square. Similarly, 257, the ones place is 7, hence this is also not a perfect square. Next, 408, the ones place is 8, hence this is also not a perfect square because the ones place ends with 8. So first 3 numbers, they end with 3, 7 and 8. So the first 3 numbers are surely not perfect squares. But if you see the last one, 441, now you can see the ones place is 1. So it may be or may not be. It may be or may not be a perfect square. But the first 3 numbers are surely not perfect squares. The third question says, find the square roots of 100 and 169 by the method of repeated subtraction. So to understand these questions, we will see one of the property of a square, that is, if n squared is a perfect square, then n squared can be written as the sum of n odd natural numbers. So sum of n odd natural numbers, that is, if you take a perfect square like 3 squared, so 3 squared will be the sum of the first 3 odd natural numbers, that is 1 plus 3 plus 5, that is we get 9. So 9 can be written as 1 plus 3 plus 5. And as we know, square root is an inverse operation of square. So here what we'll do, instead of adding, so inverse operation of addition is subtraction. So we'll repeatedly subtract these odd natural numbers and get our square root. For example, here, so I will start subtracting the first odd natural number, that is 9 minus 1, we get 8. Again 8 minus 3, we get 5, and 5 minus 5, we get 0. So till we get 0, we have to keep on subtracting these odd numbers. So here we see that how many times we have subtracted to get 0. Total it is 3 times. So this shows that the square root of 9 will be 3. Simple as that. So let's start the question now. So the first one says 100. So let's see. We'll start subtracting each odd natural numbers from 100, starting with 1. So first 100 minus 1. So 100 minus 1, we get 99. Again 99 minus 3, we get 96. 96 minus the next odd number, that is 5, we get 91. 91 minus 7, we get 84. 84 minus 9, we get 75. 75 minus 11, we get 64. And 64 minus 13, we get 51. And as we keep on moving, then 51 minus 15, we get 36. Next 36 minus 17, we get 19. And the last natural number that odd number we'll use is 19. So 19 minus 19, we get 0. So we'll count now how many times we have subtracted. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times we have subtracted. So 10 times we are repeatedly subtracting. So we can say 100. So the square root of 100 will be 10. So we can verify it. We know that 10 squared is 100. So the square root of 100 will be 10. So what we have done, we have repeatedly subtracted all the odd numbers here, 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19 till we get 0. So in the same way, we can do it for 169. So for 169, we have done the subtractions, first with 1, then with 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23 and up to 25. So finally, we have got the answer as 0. So we'll start counting how many times we have subtracted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So we can say that root over of 169. So the square root of 169 will be 13. The next question says, find the square roots of the following numbers by the prime factorization method. The first number says 729. So let's prime factorize. So in prime factorization, we will use only prime numbers. So as you can see, the number 729 will be divisible by 3. So 3 2s are 6, the remainder is 1. Then 3 4s are 12, there is no remainder. We get 3 3s are 9. Then again we can divide by 3. 3 8s are 24, 3 1s are 3. Again by 3, 3 2s are 6, the remainder is 2, so we get 21, that is 3 7s are 21. Again by 3, 3 9s are 27. Again by 3 we can divide, so we get 3 3s are 9. Hence our prime factorization is over now. So 729 can be written as 1 2 3 4 5 6. So 6 3s we have got. So 3 multiplied by 3 multiplied by 3 6 times, as you can see here. Now we'll take out the square root of these numbers. So square root of 729 will be equal to square root of this product. So as discussed, we will first find out the pairs. So pairs of the prime factors. So we'll see this is one pair, another pair, we have got 3 pairs. So from each pair we will take one prime factor. So 3 into 3 will take out 3. Again 3 into 3 will take out another 3. And the last one more pair we have, so another 3. Then only we can take out the square root. So square root of these prime factors we have taken out now. Hence we are left out with our answer 3 multiplied by 3 multiplied by 3. 3 3s are 9 and 9 3s are 27. Hence we can say root over of 729 is equals to 27. The next question, we have 400. So we'll start with 2, or else we can start with 5 also. So because 400 ends with 0, hence it is divisible by both 2 and 5. So let's start with 2. So 2 2s are 4 and 2 zeros. Again by 2 we get 100. Again by 2 we can do. So 2 5s are 10, 2 zeros are 0. Again by 2 we get 25. Now 25 is divisible by 5. Hence when we take out the square root of 400, so in place of 400 we will write the prime factorization, that is 2 multiplied by 2, 2 and 2, 4 times 2 and 2 times 5. Now our work is to find the square root of these prime factors. So we will pair them. So we get this is one pair, second pair, and this is the third pair. So while taking our square root, from each pair we will take out the prime factor. So 2 into 2 will get out 1 2 here. Again out of this pair another 2. Again out of this pair we get 5. So we can see 2 2s are 4, 4 5s are 20. So root over of 400 is equals to 20. Now the third question, it says 1764. Now we have got a bigger number. So we can see the units place is 4, so it is divisible by 2. So to do prime factorization, first of all you have to be well aware of the divisibility rules of 2, 3 and 5, so that easily we can know which numbers will be divisible by 2, 3 or 5. So as here we can do by 2, so 1 is not divisible, so we'll take 17. So 2 8s are 16, the remainder is 1. Again 2 8s are 16, the remainder is 0. So 2 2s are 4. Again it ends with 2, so I can divide by 2. 2 4s are 8, 2 4s are 8, 2 1s are 2. Now it is not divisible by 2, so we have to check with 3. Now you can see some of the digits, 4 plus 4 8, 8 plus 1 9. So hence it is divisible by 3. So as I told, divisibility rules are very much important here. So 3 1s are 3, the remainder is 1. 3 4s are 12, the remainder is 2. So we get 3 7s are 21. Again by 3 we can do. 3 4s are 12, remainder 2, so 3 9s are 27. And finally 49 is nothing but 7 multiplied by 7. So here we'll find the square root of 1764. Hence we get, we'll put the prime factorization. So 1764 is nothing but 2 into 2, 3 into 3 and 7 multiplied by 7. So from each pair we'll pair it first. So 2, 3 and 7 are paired now. So from each pair one prime factor will take out. So 2, then 3 and then we have 7. So when we multiply all of them we get 2 3s are 6 and 6 7s are 42. Hence we can say the square root of 1764 is nothing but 42. So that's the required answer. So in the same way, we can find the square root of other numbers. So as you can see, after finishing the prime factorization of 4096, so we'll find out the square root now. So we can see, we'll pair it now. So 1, 2, 3, 4, 5 and 6. We have got 6 pairs. From each pair, one prime factor we will take out. So we have 2, again 2, 2, 2. As we are having 6 pairs, we'll get 6 2s. So 6 times 2 we are multiplying. So we get 2 2s are 4, 4 2s are 8, 2s are 16, 2s are 32, 2s are 64. Hence square root of 4096 is 64. You and keep exploring.